Sounds good. I've been involved in Kubernetes since almost around 2019 or so. This was mostly from a SIG testing and an infrastructure perspective, helping Kubernetes mostly from the testing and the networking areas. My interest in deep learning stemmed from like 2018, where I was mostly doing image processing and object detections and things like that with libraries around FastAI, PyTorch, so on and so forth. And then I moved into the Kubernetes world for quite some time, and now I'm planning on integrating both of the artificial intelligence as well as the infrastructure worlds together. With GenAI becoming like the next big thing right now, one of the ideas that I've been exploring is how we can take the goodness of, say, large language models and see integrating them with controllers, because we've seen large language models like generating content, Kubernetes manifest, code, things like that. And we're trying to see how we can take already incredible amount of data that Kubernetes generates and see how we can ease out cluster operations for Kubernetes admins, for people who work on Kubernetes from a maintainer perspective, who also use Kubernetes from an end user perspective. So in a way to drive synergy between the artificial intelligence as well as the infrastructure world. So that's one of the key reasons why I'm trying to explore this area. Yeah, sure. I had this session yesterday with my co-speaker Amin, where we talked about how you can use Kubernetes, LLM-backed Kubernetes controllers to ease out cluster operations. And these cluster operations include simulating chaos. So imagine you want to test out the resiliency of a cluster. You ask an LLM to simulate chaos for it, which can mean maybe delete all of the services in the cluster, delete all of the pods in the cluster, and see if the cluster can, actually handle that the chaos that the LLM simulates. What we're trying to do over here is basically use large language models to drive out Kubernetes configuration and then write it back to the cluster. Chaos simulation is an example, but we tried out multiple other scenarios such as CVE scanning. So we've reached a point as in cloud native right now where Kubernetes has become boring. We are at the 10th anniversary of Kubernetes. The first decade of Kubernetes has been done, and as we move into the second decade of Kubernetes, we should be really thinking about how we can ease out these cluster operations. Upgrading Kubernetes clusters is not as easy right now. CV scanning is not easy right now. So we're trying to see how we can ease out this with the help of LLMs. So that's some of the things that we tried yesterday. We also tried how upgrades can be possible through Kubernetes, through the configuration generated by large language models. At the same time, being cognizant that large language models are not deterministic, that you need some human input to drive out these models to completion and see through the upgrade. All in all, having an LLM as an auxiliary, but with a domain expert like an infra engineer helping out, carrying out their operations. So that's the crux of that session. Thank you for that. As of now, the LLMs that are publicly available are through an API access. What really needs to be done in this space is to carve out LLMs which we can train on custom data sets. This requires quality data. So one of the things that we've been looking at is to how we can create data sets around Kubernetes configurations without any copyright issues and things like that. So one of the things is like a kubectl data set which is publicly available, but the idea is to have a data set, have a fine-tuned LLM model that you can create, where you have control over the data, where you have control over the model, and you have control over how you execute that model. So these are the key areas, these are the key hurdles that we're kind of facing as of now. This is a very nascent state, but we see a lot of potential in an area like this, which is at the intersection of Kubernetes controllers and LLMs in the near future. So the future is right at our doorstep. So this is something that we want to tap in right now, explore this use case out in the open. So we're exploring this use case in a project called as LLM NetEase, which is an open source project. It's again at a very nascent state. All of these ideas that I've discussed as of now are part of this project. We also talked about it at the session which I mentioned earlier. But the idea is to say how software supply chain principles are incorporated into tools like this, how data privacy, data ethics, basically keeping responsible AI in mind is taken into consideration while we work on tools like this. So the hurdles basically remain at how we navigate through all of the challenges, the lack of data, and how we build quality models, with quality data, having all of these other variables in our control. Cluster. So one of the things that I see, or I want AI or LLM models to get to the table, is that explaining me why the cluster is failing or why there are certain errors in the cluster is not enough. We want next steps in order to fix that cluster, or fix what are the issues that lie in the cluster. Help cluster admins, domain experts take up all of these insights from the model, but also get some actionable next steps. The other thing that I want to see is how accountability of the model is kept into the picture, wherein we should have the ability to disagree with the LLM. LLMs are mathematical functions. They're not deterministic as of now. They give an output with a probability. The generated outcome may not be 100% accurate. It'll be based on the pre-trained data that it had available at the time of training that model. So taking all of these factors into consideration, if you're building tools around integrating LLMs with Kubernetes controllers, we should be cognizant of the fact that the outcome that's generated by this may be counterproductive to the cluster. And in such a case, we need accountability. We need a functionality in the tool wherein you can actually tell the model that the outcome that was generated was not accurate, and you can in turn help feedback that corrected output back into the data set, fine-tune the model again, and recorrect the course of the model in a way that it corrects itself. These are some of the ideas around having responsible AI into the picture. The other ideas that I see mostly from integrating artificial intelligence in something like Kubernetes is to have it as an auxiliary, something that people can use, something that makes the lives easier, not only for like experts, but also for people getting into say Kubernetes. This helps them play around with Kubernetes clusters. And also this bridges the gap between the two domains. So currently there are two domains around cloud native and artificial intelligence. As much as we need to integrate artificial intelligence in cloud native, we need cloud native engineers to adopt the skill of artificial intelligence. That involves skill of training data, that involves skill of taking into the consideration of data ethics into your mind, that involves inference. So all of the data science principles into account, which can be learned as a skill. At the same time, we need to see how we can take the cloud native goodness into the artificial intelligence world, and keeping open source at the heart of it, right? So the idea is to balance these things out. The idea is to build synergies between these two domains, and the idea is to have like a more innovative, boring future.